In the section 5, we will be discussing about a gambling decentralized application. We have a contract ready for the gambling decentralized application. We will discuss about the front end and how to connect with the back end and then deploy this application. Today in this video, we will be learning about re-entrancy, randomness in Solidity, and also Solidity for handling bets. Firstly, we will discuss about private information and randomness. Everything you use in a smart contract is publicly visible, even local variables and state variables which are marked private. Reentrancy problems are always big or small, we can't say, but of course we need to avoid it. We need to take measures to avoid reentrancy problems. To avoid reentrancy, you can use the checks, effects, interaction pattern as outlined. I'm briefly explaining the documentation which is present in Solidity website. The documentation, it explains clearly about the reentrancy and how to solve it, how to avoid it. Note that reentrancy is not only an effect of ether transfer, but also any function call on another contract. Gas limits and loops that do not have a fixed number of iterations, for example, loops that depend on storage values, have to be used carefully. This is due to the block gas limit. Transactions can only consume a certain amount of gas. Either explicitly or just due to normal operation, the number of iterations in a loop can grow beyond the block gas limit, which can cause the complete contract to be stalled at a certain point. This may not also apply to view functions that are only executed to read data from the blockchain, but still, such functions may be called by another contracts as part of on-chain operations and stall those. Some of the recommendations I would suggest you are take warnings seriously. Now, when I say warnings, I'm talking about the compiler warnings. Most of us, including me, don't take warnings quite seriously. The compiler, when it states there is a warning, it can actually cause an issue when combined with other warnings or any loopholes. Neither contract nor external accounts are currently able to prevent that someone sends them ethers. This is one restriction about the amount of ether. If a contract receives ether without a function being called, the fallback function is executed. If it does not have a fallback function, the ether will be rejected by throwing an exception. There is a way to forward more gas to the receiving contract using address.call.value. Keep it small and modular. Keep your contract small and easily understandable. Single out unrelated functionality in other contracts or into libraries. General recommendations about source code quality of course apply. Limit the amount of local variables. You can always limit the amount of local variables. The length of a function can be limited too. Then comes use the checks, effects, interactions pattern. Most functions will first perform some checks. Who called the functions? The arguments in range? Did they send enough ether? Does the person have tokens? Etc. These checks should be done first. As the second step, if all checks passed, effects to the state variables of the current contract should be made. Note that all calls to the known contracts might in turn cause calls to unknown contracts. So it is probably better to just always apply this pattern. Finally, include a fail-safe mode. What does that mean? While making your system fully decentralized, it'll remove any intermediary. It might be a good idea, especially for new code. To include some kind of fail-safe mechanism, you can do in different ways. You can add a function in your smart contract that performs some self-checks like has any ether leaked? Is the sum of the tokens equal to the balance of the contract? Or similar things.